Hey students, this is lesson 833. In this lesson we're going to learn how to take a quadratic equation and solve answers with it, just knowing what the different parts are. We're going to do this question in class, and so I'm going to skip to page 15 in your handout. And we're going to do this problem about the kicker. It says a place kicker on a football team attempted 3 field goals during practice. All 3 were kicked from the opponent's 40-yard line, which is 50 yards from the goalpost. For a field goal to count, it must clear the crossbar, which is 10 feet high. The football followed a different path through the air for each kick. These equations give the height of the kick in feet for any distance the kicker in yards. So each kick was aimed directly at the center of the goalpost. So here's the 3 kicks and a different equation for each one. And it says for kick 1, plot enough points to make a smooth curve. We're not going to do that. We're just going to use our calculator. So we're going to graph this. Now, one thing we have to remember here is this equation is a little different. We don't have time now. We have height is the output of the function, and the input is the distance in yards that the kick goes. So we're going to use those 2 things. So I'm going to set up my calculator here with this equation. So here's our equation for the first kick. Now I decided to show you how I'm going to set up the window here so you could see that. So I'm going to go to my window. Now one thing we have to remember is that x stands for the distance the kick is that it goes. So remember, we're kicking this thing about well, to make this field goal, we have to kick it 50 yards, so I'm just going to go from 0 to 60. See how that works in a scale of 5 seems to make sense, so every 5 yards. So that stands for how many yards it's kicked. And then y is the height of the kick, so I'm just going to go from 0 to, I'm not sure how high it's going to go, but I'll just say, so it's about 50 feet. So x is in yards and y is in feet. All right, now I'm going to graph this. So I can get a look at, this is the kick. And on my axis, I went by 5, so this is like 10, 20, 30, 40. All right? And my question B, if you look at that, it says use your graph to estimate the maximum height of each kick. Okay, now to do that, we need to trace. And we need to be up by the maximum. And then you go second trace, and we pick number 4. Now you have to set some boundaries. You have to know where the maximum is, and it says left bound, so I need to go to the left side of where I want the calculator to figure out the maximum. Press enter. Then I'm going to go to the right side, press enter, and press enter one more time. And now remember, this is an estimate. The calculator can't get this perfect, but it's saying that the height, which is y, is about 40.1 feet. So I'm going to put that answer in here. So we have 3 kicks that we need to answer this for: kick 1, kick 2, and kick 3. And kick 1, it says estimate the maximum height, and we said it's about 40.1 feet. All right? Then we're going to use our graph to estimate how many yards each kick traveled over the field before it struck the ground. So I'm going to go back here. Now, what I'm talking about there is when the height of the ball is 0, that's when it lands, which is down close to it is the x-axis. So I'm going to use another function to find that. And you can see from this that x is 43 right now, so it's somewhere between 40 and 50 feet. But there's another function we can use here. Once we trace, we can go second trace. And here I want to use the number 2, which is the 0. Okay? And again, we have to set boundaries. Now I know the 0 is somewhere between this line and this line. So we need to set a left boundary and a right boundary. Your left boundary, when you're finding the 0, has to be positive number for y, and your right bound has to be a negative because there's 0 somewhere between the positive and the negative. So press enter for the left bound. Then I'm going to press my right arrow till y becomes negative. Press enter again, and then press enter one more time. And it says a little over 45, so we can say about, so how many yards did the kick travel? It was a little over 40 yards, 45 yards. Okay, now question D says to make a field goal, the football must cross the goalpost. That means it must be at least 10 feet high when it reaches, when it's 50 yards from the kicker. So some of you are thinking, well, it didn't even go 50 yards, so this one definitely is going to work. But I'll show you how to find that value. If you press trace, you can now enter any x value you want, and we want to enter 50 yards into x, and we want to know what y is at that point. And that's negative 19.5. We need that to be higher than 10 feet for this to work. So it definitely didn't make it. The height of the ball is negative 19 feet, and that's because it had already hit the ground. So the answer is make a field goal. We're going to say no, it didn't make it. And our reason we know that is because 50 gives a height of negative 19.5. So when we're 50 yards, that's our distance is 50. Our height is negative 9.5. All right, let's go ahead and do kick 2. And so we're going to put a different equation into our calculator. And you can go ahead and do this and get these answers ahead of time and just check back with your answers if you want. All right, so I got my second equation in here, and I'm going to press graph. And this one doesn't go up so high, but it seems to go a little farther. Now remember, my scale here is 5, so that's 10, 20, 30, 40, 50. This one goes far enough to make the field goal. Later on we'll check to see if it's high enough. But first thing first, we're going to find the maximum again. So I'm going to press trace, and then I'm going to press second trace, and number 4. And then I'm going to set my left bound, which is I need to be on the left side of the maximum. And then I'm going to set my right bound, which I need to go to the right side of the maximum. Press enter, and then one more time for it to guess what the max is there. And it's guessing 28.4. So let's record that in our notes here. So 28.4 feet high. All right, and then it says how many yards did the kick travel, so that's where we want to find out where it gets to the ground. So we want the output to be 0. So we're going to trace to that point of the graph where it touches the x-axis. I think I'm close enough. Now remember, when you set your left bound here, the number needs to be positive. So let's do number 2, find the 0. And our y value is positive now, so that's good for our left bound. Our right bound, the y value has to be negative. So we're going to keep going until we get negative y value. Now we're good. Press enter. Enter one more time. And it says 56.9. So that's how long the kick is, 56.9 feet. Oh, that should be yards, right? 56.9 yards. Okay, and now we're going to see if it actually made it. And then what that means is when it's 50 yards, it needs to be 10 feet high. So we're going to check with our calculator and see. I'm going to press trace, and then I'm just going to enter 50 into the calculator. Press enter, and that'll go right to that spot. And we can see that it is 8.5 feet high, and it needs to be 10 feet high. So this one would cross underneath the goal post. And another way I could show the goal post is I could put an equation in y2 for the height being 10. And if I graph that, that line would represent the goal, the horizontal crossbar of the goal post. And then if I trace now and I go to 50, you can see that that cursor is a little bit below that line. So didn't quite make it. All right, so let's record that. So no, it went, it's 8.5 feet high at 50 yards. All right, and that's going to be the end of the lesson. I'm going to let you finish it up, find kick 3, see if that one made it or not, and then we'll do the rest of them in class. I'll see you tomorrow.